Now that you have designed role-based access control for least privilege on Azure, you are ready to protect what attackers actually want: your data, your secrets, and the keys that unlock everything. Least privilege controls who can act, but key management controls what can be protected even if someone gains access. If you treat keys and secrets casually, you can have strong governance and still lose control through credential theft, leaked secrets, or weak encryption practices. This lecture helps you design a key management architecture that leaders can trust and architects can defend. With that context set, you need to frame key management as a leadership responsibility because it directly influences breach impact, compliance outcomes, and business continuity. When encryption keys are protected and controlled, data exposure becomes harder and incident scope becomes smaller. When keys are unmanaged, the organization becomes fragile because a single leaked secret can turn into wide access and rapid damage. Leaders care because key failures become reputational and legal crises. Architects care because key management is foundational to every secure workload pattern, not an optional add-on. With leadership importance clear, you now establish simple vocabulary so your organization speaks consistently. A secret is typically a sensitive value such as a password, connection string, or application token. A key is used to encrypt or sign data, and it must be protected because control of the key often means control of the data. A certificate supports identity and trust, enabling secure communication and authentication. When you keep these concepts distinct, you design the right controls for each and avoid the common mistake of treating everything as just a password. With the vocabulary in place, you now introduce Azure Key Vault as a central control plane for secrets, keys, and certificates. Conceptually, Key Vault is not only storage, it is policy, access control, auditing, and lifecycle management for sensitive material. It provides a consistent place to manage how secrets are accessed, how keys are used, how certificates are rotated, and how evidence is captured. Leaders value Key Vault because it reduces risk through central governance. Architects value it because it provides a repeatable pattern that teams can adopt without inventing their own secret handling practices. With Key Vault defined, you now state the architectural goal clearly. Your goal is to eliminate secret sprawl, meaning secrets scattered across code, configuration files, laptops, and unmanaged storage locations. You also want to reduce key exposure, meaning keys that can be exported, copied, or used without strong access controls. When secrets and keys are handled consistently, your security posture improves and your operational readiness improves because you can rotate, revoke, and audit access centrally. With the goal clear, you now define encryption strategy as 3 parts that leaders can understand. Data at rest is the data stored in disks, databases, and object stores, and encryption protects it if storage is accessed unlawfully. Data in transit is data moving over networks, and encryption protects it from interception and tampering. Data in use refers to data being processed in memory, where traditional encryption is harder, and protection often relies on identity, access control, and secure execution environments. Your key management architecture ensures encryption is not a scattered set of settings, but a coherent strategy aligned to risk and compliance. With encryption strategy set, you now address ownership because keys represent power. In some models, the platform manages encryption keys transparently, reducing operational overhead. In other models, your organization manages the keys, often called customer managed keys, to meet regulatory requirements or stricter control expectations. The decision is not only technical, it is about governance, accountability, and operational maturity. Leaders care because key ownership affects compliance and risk exposure. Architects care because key ownership affects design complexity, availability dependencies, and recovery procedures. With ownership model explained, you now clarify when customer managed keys are justified, so the organization does not adopt complexity without benefit. Customer managed keys are often worth it when regulatory obligations require stronger control, when sensitive workloads demand clear key separation, when you need the ability to revoke access by controlling keys, or when the organization must demonstrate governance over encryption beyond default platform controls. The leadership decision is whether the increased operational responsibility is justified by risk reduction and compliance needs. The architectural decision is whether you can operate keys reliably without creating new single points of failure. With customer managed keys discussed, you now address the operational truth that keys themselves can become a critical dependency. If a workload depends on a key vault for encryption operations or secret retrieval, and that key vault is unavailable, the workload can fail even if everything else is healthy. This is why key management is tightly connected to reliability and disaster recovery. Leaders care because they do not want a security control to become a business outage driver. Architects care because you must design for resilience, such as regional redundancy strategy, controlled access patterns, and recovery plans for key services. With availability implications clear, you now bring role-based access control principles into key management because access to keys and secrets is higher stakes than ordinary access. You design access so only the right identities can retrieve secrets, and only specific workflows can use keys for encryption and decryption operations. You separate administration of the key vault from consumption of secrets and keys. You also ensure privilege access is time-bound for sensitive operations. Leaders value this because it reduces insider risk and blast radius. Architects value it because it preserves accountability and supports audit requirements. With access control set, you now focus on the practical pattern that reduces incidents, remove secrets from code, and reduce human handling. Your architecture ensures applications and automation retrieve secrets securely at runtime rather than embedding them in configuration files or pipelines. You also reduce manual secret sharing through email or chat, which is a common cause of leaks. Leaders care because secret leakage often becomes a public incident. Architects care because secure retrieval patterns improve reliability and reduce emergency secret rotation events caused by accidental exposure. With retrieval patterns established, you now address lifecycle because every secret and key will eventually need to change. Rotation is not a nice to have. It is your safety mechanism when exposure happens, when stab changes occur, or when policy requires renewal. Your architecture defines rotation expectations, ownership, and schedules aligned to risk. It also defines how expired secrets are detected before they cause outages. Leaders care because rotation reduces long-term exposure risk. Architects care because rotation without planning causes production incidents, so lifecycle management must be designed, tested, and operationally supported. With keys and secrets addressed, you now include certificates because enterprise systems rely on trust relationships. Certificates support secure transport encryption and service authentication, and they often have strict expiry timelines. Your architecture ensures certificate issuance, renewal, and deployment are governed and auditable. Leaders care because certificate failures cause outages that look sudden and avoidable. Architects care because certificate lifecycle is a dependency chain that must be managed reliably, especially in large environments with many services and integrations. With lifecycle covered, you now focus on auditability because key management without evidence is not governance. You design logging and monitoring around key vault access, secret retrieval, key usage operations, and administrative changes. You want to detect unusual access patterns, excessive retrieval attempts, and unexpected administrative actions. Leaders care because audits and incident investigations require evidence. Architects care because monitoring provides feedback loops that reveal misconfigurations, over-permissioning, and risky usage patterns before they become incidents. With evidence in place, you now connect key management back to Azure policy and governance because consistency is how you scale security. You define standards for what must be stored in Key Vault, what must never be stored in code, what encryption expectations apply to different data classes, and what access and rotation requirements are mandatory. You also define exception handling for cases where legacy constraints exist. Leaders value this because it makes compliance defensible. Architects value it because it reduces design churn and prevents every project from inventing its own secret strategy. With governance clear, you now ground the value in a scenario that happens in real enterprises. Imagine a developer accidentally commits a connection string to a source code repository. If that connection string is long-lived and grants broad access, the organization faces immediate risk and urgent incident response. In a strong secrets architecture, that secret is not stored in code. Access is scoped and time-bound, and rotation can happen quickly with minimal disruption. Even if a secret leaks, the blast radius is limited and the recovery is controlled. This is how key management changes outcomes. It turns panic into procedure. Let's now discuss the key takeaways from what you learned so far so you can design key management that leaders trust and architects can defend. Key management is a leadership topic because it determines breach impact, compliance posture, and operational continuity. You must treat keys, secrets, and certificates as distinct assets with different controls and life cycles. Azure Key Vault provides a central control plane for sensitive material, reducing secret sprawl and enabling consistent governance. Your encryption strategy should cover data at rest, data in transit, and data in use, and you must choose key ownership models intentionally, including when customer-managed keys are justified. Keys and secrets create availability dependencies, so resilience and disaster recovery planning must include key services. Least privilege access, secure retrieval patterns that remove secrets from code, and strong rotation practices are essential for reducing long-term risk. Certificates require disciplined lifecycle management to prevent outages, and auditability through logging and monitoring turns key management into a governable capability. Finally, standards and governance make key management consistent across teams and prevent the organization from accumulating hidden secret risk. If you want your Azure workloads to be secure by design and resilient under real-world pressure, subscribe so you can continue through the rest of this playlist and complete the enterprise Azure architecture journey. Like this video, so more leaders and architects learn how to design secrets and encryption properly. Comment with your biggest key management challenge, such as rotation governance, customer managed keys, or reducing secret sprawl, and share this with your team so you can standardize secure key and secret handling across your organization.